As far as anti-malware is concerned, we detect a threat as a threat. So we don't split up, we don't have particular modules that look for spyware and adware and things along those lines. So I like to mention that, a threat is a threat to Kaspersky. The way that we detect threats, we do have a modular approach to this. So we have certain aspects down the left-hand side here, as we can see. So for instance, we have an instant messaging antivirus component to scan IM protocols and different messengers there. We have a web antivirus component to block the download of malicious scripts and malicious actions that may be caused within the browser. So this is even before it hits the file system, I should add. We also have a mail antivirus scanner there as well to scan on the usual protocols, and by default port 25, you can add in other ports there as well to give a additional layer of protection. Again, it's another vector that the malware can target, and again it's something that Kaspersky can cover off before it hits the file system. If there is anything residing on the file system, then we do have a kernel level antivirus engine, the file antivirus component here. Our engine works in such a way that it intercepts every input-output operation. So this is really the scanning engine, traditional scanning engine that you'd think of that. The way that it works, it also benefits from the iSwift and iChecker technologies that I spoke about earlier with the scans, and we can work in an intelligent way there also. All of these components I've just briefly mentioned benefit from heuristic analysis as well as signature analysis, so there's behavioural analysis in place there as well. The one thing that we do that's a new feature and quite exciting to the Endpoint Security 8 product is something called System Watcher. Now, System Watcher has been in the Kaspersky solutions for a number of years. We've just recently brought it into the corporate edition here. What System Watcher does is to proactively monitor the system for new threats. So it's our way of knowing the unknown and tackling zero-day threats. How do we do this? Well, say for example there was a brand new piece of malware, so it's just to us it's just a piece of code. We don't know what it is, we don't know its history, we don't know that it's going to act in a bad manner. So for instance, this zero-day threat may reside on the file system. At some point in time, this zero-day threat will do something malicious. It has to. By nature, malware needs to access the operating system. It needs to access resources such as writing to the auto-running registry, to start logging user data, to spawn processes, to create DLLs, etc. When that action occurs, the System Watcher will kick in. By default, Kaspersky's operations are there to block malware, to attempt to disinfect it and delete it if disinfection fails. So that will occur. We can also roll back the malware actions that are caused. So if anything detrimental has happened to the system, we can roll those actions back. Not only can we do that, but then we can build up a pattern of that dangerous activity and that dangerous behaviour. That pattern can then be uploaded to the Kaspersky security network. So the KSN, again, this is our cloud-based technology. So we're leveraging all of that information that we have in the cloud, and we can upload this pattern of dangerous activity to the cloud. Millions of subscribers to the KSN can then benefit from this pattern of dangerous activity by downloading it onto their machines. So what I'm talking about here is really a way of detecting malware in a very instant and urgent way. So we have an urgent detection system here. Obviously benefits and leverages the System Watcher there. So this little scenario that I've spoken about does happen, and happens on a very frequent daily basis, and it can occur in a virtually instantaneous manner. The statistics that I've seen talk about 40 seconds from detecting an unknown threat to knowing its behaviour, knowing how it acts, uploading that to the Kaspersky security network, and that information being passed down to every subscriber of the KSN. I like to mention that because I think that's a very intelligent way of proactively monitoring each endpoint machine, but sharing that information in an anonymous manner, and everybody benefits from this. The other benefit is that we can, along with the knowledge that we build up about executables and how they act on a machine, we can reduce false positives as well. So we're increasing our reactive and our proactive detection technologies and reducing false positives as we go. We also have a client-side firewall. If you need to run with this, then you can create networks. So maybe that you've got certain networks that may be a public facing network, and you can set those up with the zones. That in turn has certain restrictions automatically placed on it, such as stealthing any unused ports and restricting net BIOS, and file and print sharing wouldn't be allowed. It might be that it's a local network, and in that scenario, then yes, file and print sharing would be allowed, and all the usual things that need to be accessed on a network would be allowed. Or it could be specifically a trusted network. Now, again, we can leverage our knowledge of applications within the KSN, so the rules can be automatically propagated in. Mine currently aren't, unfortunately, here, but you can have those rules propagated in. So that means that we know that Internet Explorer needs to access HTTP and HTTPS on the usual ports, so we're not going to be bugging the end users and prompting them for allow and denies and issues along those lines. So much of the firewall rules can again be automated. We also have a network attack blocker there, so this is in place to slow down the propagation of malware on the network. So there's certain network aware worms, and we can block those. So that's really where the feature